Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can help me promote my channel to keep me going, inspired and refreshed. Now, if you like my videos, if they are important to your studies, then also don't forget to subscribe. Analyze the frame shown by moment distribution method. Determine the moments at all joints. So here is the given figure. So we have 3 for the sloping member, 3, 4, so the length is 5. So the stiffness is 1 over 5. This member is also 1 over 5, the stiffness. And this member has a stiffness of 1 over 4. So this is the anticipated deflected shape. So let's relate the side sways for BC and CD in terms of the side sway displacement of member AB. So take note that this is theta, the angle between the vertical and the line perpendicular to the sloping end. So therefore, delta BC is delta cosine of theta, and cosine theta, which is this theta here, is 3 over 5. And it is equal to delta BC over 5 over delta. So delta BC is 0.6 of delta, while sine of theta or delta CD is delta sine of theta, and sine theta is 4/5, so 0.8 of delta. Since this angle rotates, the chord BC rotates counterclockwise, this is treated negative, this one, sorry, and delta and 0.8 delta treated positive in the side sway moments, which is negative 6 EI delta over L square. So side sway moment for AB is negative 6, EI is 1, delta is delta then over L square, so 5 square, negative 6 delta over 25. For BC, negative 6 times 1, negative 0.6 delta over 5 square. This is treated negative counterclockwise rotation from slope deflections sign convention, so 8 delta over 125, while for CD or DC, negative 6 times 1 times 0.8 delta over 4 square, and it is negative 3 delta over 10. So the LCD of the denominators 25, 125, and 10. 125 is 5 cube, 10 is 2 times 5, so 2 times 5 cube, that's the LCD, or 250. Multiplying this by 250, so I'm treating delta as 1, so negative 60 kilonewton meter. Multiplying this by 250, this is 36 kilonewton meter. And multiplying this by 250, this is negative 75 kilonewton meter, the side sway moments. The first sway moments would be 0 because none of the members has load between the ends or between the joints. So therefore, first phase moments would be 0. So let's proceed to the second phase. So the distribution factor for A is 0. This is also 0 for D. For BA, it is 1/5 divided by 1/5 plus 1/5, negative. So negative 0.5, that's also negative 0.5. Then for CB, negative 1/5 over 1/5 plus 1/4, negative 4 over 9. So this is negative 5 over 9. Then let's put the side sway moments. For AB, we have negative 60, negative 60. For BC, 36, 36. And for CD, negative 75, negative 75. So let's just put the moments here. We might run out of space in that direction. So at this joint, it's 0. So I will not just put 0. The distribution factor is 0 for A and D. So we begin with B. So quantity negative 60 plus 36 times negative 0.5 is 12 lakh. This is also 12 lakh. Quantity 36 minus 75 times negative 4 over 9 is 17.333 lakh. So here times negative 5 over 9, so 21.667 lakh. Here it's 0, so I will not just put 0. Carry over, so remember the distributed moment is 0, so half of 0 is 0 there. I will not put 0 to save space. Half of 12 is 6. Half of 17.333 is 8.666. Half of 12 is 6. Then half of 0 is 0 there. So half of 21.667 is 10.834. So 8.666 times negative 0.5 is negative 4.333 lakh. This is also negative 4.333, so lakh. And 6 times negative 4 over 9, negative 2.667 lakh. 6 times negative 5 over 9 is negative 3.333 lakh. Then 0, 0. Carry over, so 0 here. Half of negative 4.333 is negative 2.166. Half of negative 2.667 is negative 1.334. Half of negative 4.333 is negative 2.1667. So 0 here. Half of negative 3.333 is negative 1.666. Then distribute negative 1.334 times negative 0.5 is 0.667 lakh. It's also 0.667 here, lakh. Negative 2.166 times negative 4 over 9 is 0.963 lakh. Negative 2.166 times negative 5 over 9, 1.203 lakh. Then carry over, 0 here. Half of 0.667 is 0.334. Then half of 0.963, 0.482. Half of 0.667, 0.334. 0 here. Half of 1.203, 0.602. 0.482 times negative 0.5, negative 0.241 lakh. 0.482 times negative 0.5, negative 0.241 lakh. 0.334 times negative 4 over 9, negative 0.148 lakh. 0.334 times negative 5 over 9, negative 0.186 lakh. Then carry over, 0 here. Half of negative 0.241 is negative 0.120. Half of 0.148, negative 0.074. Half of negative 0.241 is negative 0.120. Then 0 here. Half of negative 0.186 is negative 0.093. Negative 0.074 times negative 0.5 is 0.037 lakh. Then half. Then 0.037 here, lakh. Negative 0.12 times negative 4 over 9 is negative 0.053 lakh. Negative 0.12 times negative 5 over 9 is 0.067 lakh. Then carry over, 0. Half of 0.037 is 0.018 lakh. Half of 0.053, 0.02, half of 0.037, 0.018. Then 0 here, half of 0.067 here, 0.034. So 0.026 times negative 0.5, negative 0.013 lakh. Then final lakh. That's very small already. Negative 0.013 lakh partial final lakh. 0.018 times negative 4 over 9, -0.008 lakh final lakh times -5/9, -0.010 lakh final lakh, then half of -0.013, -0.006 lakh final lakh, half of -0.010, -0.055 lakh final lakh. Then adding moments, -55.94 here, here, -51.883, adding these values, 51.883, adding these values, 55.592 here, -55.592, then here, -65.294. So therefore, moment AB is negative. So let's have our static equation in order to solve for the constant ratio R. So we sum up moments about O. Let's find O. Let's call that theta. Let's call this YZ. And remember the slope 3, 4, 5. So Y as to 4 equals this distance 5 as to 3 equals Z as to 5. Then these are the support reactions at A, support reactions at D. And let's assume clockwise moments for MAB and MDC. So Y as to 4 equals Z as to 5 equals 5 as to 3. So Y is 20/3 and Z is 25/3 meters. MAB therefore is -55.940 R. MBA is -55.883 R. BC 55.883 R, and CB is 55.592 R, MCD -55.592 R, MDC is -65.294 R. So summation moment O is 0, VA times 5 plus 25/3 plus V sub D times 4 plus 20/3, then plus 120 times Y, which is 20/3, equals MAB plus MDC. Simplifying, take note that VA is, if you consider a free body diagram of AB, V sub A times 5 equals MAB plus MBA. So therefore, this is 1/5 of quantity MAB plus MBA. So 1/5 of MAB plus MBA times 40/3 plus 1/5 of 1/4 other of MDC plus MCD, this one, V sub D. If you draw free body diagram of CD, summation moment about C, so V sub D times 4 equals MDC, then take note there is MCD here, which is assumed clockwise. So 1/4 of MDC plus MCD times this is 32/3, then plus 800 equals MAB plus MDC. Simplifying, 5/3 of MAB plus 8/3 of MBA plus 5/3 of MDC plus 8/3 of MCD equals -800. So let's use this equation on the next slide, and let's substitute MAB, MBA, MCD, and MDC. So take note that this was the equation we established: 5 thirds MAB plus 8 thirds MBA plus 5 thirds MDC plus 8 thirds MCD equals negative 800. So the figure, the values of moments, terms of R, the figure. So 5 thirds of quantity negative 55.94 R plus 8, multiply everything by 3, plus 8 of MBA negative 51.883 R plus 5 MDC negative 65.294 R plus 8 of MCD negative 55.592. Negative 800 times 3 is negative 2,400. So simplifying, solving for R is 1.63714. So MAB therefore is negative 55.940 of 1.63714. So MAB is negative 91.582, which is moment at A. MBA negative 51.883 of 1.63714. So MBA is negative 84.940 kilonewton meter. Therefore, MB, which is MBC, is 84.940 positive. MCB is 55.592 kvar. So MCB is 91.012 kilonewton meter. So that means MC, which is MCD, is negative 91.012. And finally, MDC, which is negative 65.294 of R. MDC is negative 106.895 kilonewton meter. So MD is positive 106.895 kilonewton meter. So that's it for this problem.